use mathematical induction to prove the following statement. The sum from r equal 1 to n of r minus 1 in bracket, is equal to n times n squared minus 1 in bracket, divided by 3. Alright. Now, I want you to pause the video and make an attempt at this one. Okay, have you finished? Now, let's talk about this thing for a while before we start. This, is the sum from r equal 1 to n. That means suppose you had sum from, say, r equal 1. So it's 1 times 1 minus 1. Now you count, it would be 1 alone. So r equals 1. So it's r is 1. N would be 1 because n is the number that you stop counting. So you have 1 squared minus 1 over 3. Both sides will give you 0. 1 minus 1 is 0. 0 times 1 is 0. 1 squared minus 1 is 0. Right? So both sides are equal. So remember now, r goes from 1 to 2, 3, and so on and so forth, to up to n. So n is the number of terms that you have. Alright? So n is number of terms. Suppose you count up and say r is 2. You have to start at 1 first. So when r is 1, you have 1, 1 minus 1, plus when r is 2, you have 2, 2 minus 1, and so on. Well, r is 2. You stop at n, which is 2. So in the right hand side, you have 2 times 2 squared minus 1 over 3. So this would be 0 plus 2 minus 1 is 1, 2 1 is 2. And what you have up here, 2 squared is 4. 4 minus 1 is 3, so it's 2 over 3 times 3. So 3 is cancelled, so 2 equals 2. Alright? If it was 3, then you would say, you start off when r is 1. So it's 1 times 1 minus 1 plus r is 2. 2 times 2 minus 1 plus when r is 3. It's 3 times 3 minus 1. 3 is where you stop counting, so that's n. So n would be 3. So that would be equal to 3 squared minus 1 divided by 3. So in dealing with this, 1 minus 1 is 0, 0, 1 is 0. See that? Plus 2 minus 1 is 1, 1, 2, 2. Plus 3 minus 1 is 2, 3, 2, 6. So this would be 8. Let's see if the right hand side works out like that too. It's 3 times 3 squared is 9. 9 minus 1 is 8. So it's 3 times 8 over 3. 3 cancel 3, so you get 8. And so on and so forth. So r changes. I should write here. R changes. It goes 1, then 2, then 3, up to where you stop. That's n. Alright. Now, when it comes to a question like this, mathematical induction, you must prove what they call the base case. Right? Or usually it's written show. So, show that the proposition involving 1 is true. So you start off at 1 and you go upwards. But anyway, to show that, you're going to have n equal 1. But r is also 1 because that's the only value you have, right? If it was n equal 2, you have r equal 1 and then r equal 2, you have n equal 3, it would be r equals 1, then r equal 2, then r equal 3. 3 is where you stop counting, right? Now, we're going to substitute. You have only one term, so you just say 1 times 1 minus 1. So it's 1 times 1 minus 1. One times 1 minus 1 is equal to 1 squared minus 1 is equal to 1 squared minus 1 divided by 3. So here, this part will be 0 equals 0. So you say P1 is true. Now, the next thing is you're going to assume that PK is true. Now, if you show P1 is true, the next step would be to show P2 is true. But if 2P is true, if you show that 2P is true, the question is what about P3? And if you show them all up to P100, the question is still what about P101 and so on? Or what about P2, P3? If you miss those out, you have to show it valid for all numbers. So K now is not a specific number. It can be any number you want. It's a variable. Alright? So there can be no argument about whether you are showing, whether you're missing out a number. Alright? There's going to be an argument about what happened after the K, but we'll see that later on. So you assume that PK is true. So when that happens, N is equal to K. So let's write that down. You have the sum from R equal 1 to K. So it's the sum from R equals 1 to K of R minus 1, R minus 1 is equal to K squared minus 1. You have K squared minus 1 divided by 3. Divided by 3. Okay? So you see that. Now, if you show from R equal 1 to K, the next thing is what happened to the next term? Right? So you're going to show that P K plus 1 is true. PK plus 1 is the next term in line. Alright? Because if you show it for all numbers and you say one of the numbers is K, you must show it true for the other number. That if you start at 1 and then you say K, suppose K is 2, then you show that, but what about 3? Suppose K is 3 then. You show it for 3. What about 4? And so on and so forth. So 4 will be 3 plus 1. So in this case, you show that PK plus 1 is true. So in this, what happened is that N, oh no, open here. n is equal to k plus 1. So let's see how it goes now. R equals the sum from r equal 1 to k plus 1 of r minus 1. Sum from r equal 1 to k plus 1 of r minus 1 equals, now remember, n is k plus 1, so we're going to change n to k plus 1. So it's k plus 1 open bracket, it's k plus 1 open bracket, k plus 1 squared, what happened after this again, minus 1 all over 3, minus 1 divided by 3. All right. Now, there's a problem with this part. You haven't seen, it was not shown what the sum from r equal 1 to k plus 1 are of r minus 1. What that is, what kind of expression that is. I see it shows from r equal 1 to k, but what about r equal 1 to k plus 1? Alright, what you could do, since you know that the sum from r equal 1 to k of r minus 1 is k squared minus 1 over 3. What you do is to separate, you're going to separate the sum from r equals 1 to k plus 1 into the sum from r equals 1 to k, then add the k plus 1th term. Alright? So that's what you're going to have to do. It's like you're saying, you're summing. Think he's moving. It's like you're saying you're summing from r equals 1 to 6. Let's say 1 plus 2 plus 3 plus 4 plus 5 plus 6. But 6 is 5 plus 1. So you say, alright, going from r equal 1 to 5 plus 1 is the same as summing up from r equal 1 to 5. Right? Then you add this. Alright? The 6th term, which is the 5 plus 1th term. Same thing. So what you do is this now. You're going to sum from r equal 1 to k. For r equal 1 to k. Find the sum from r equal 1 to k of r minus 1 is equal to, then you have k plus 1, k plus 1 squared minus 1, so you have k plus 1, k plus 1 squared minus 1 over 3 divided by 3, alright? Oh, I missed out something. Yeah, we separate this into the sum from r equal 1 to k, then add the k plus 1th term. So we're going to say plus the k plus 1th term is equal to this. It's over what, 3? It's over 3, right? Now, the sum from r equal 1 to k of r minus 1. What is that? Here it is. it is, oh, here it is, I mean, it is k squared minus 1 over 3. See? The sum from r equal 1 to k of r minus 1 is equal to k squared minus 1 over 3. It's k squared minus 1 over 3. So this part is k squared minus 1 divided by 3 plus, then this part now, what is the k plus 1th term? Alright, we're going to have to think about that. What the k plus 1th term? You see, the first term is when r is 1. So you have 1 minus 1. The second term is when r is 2. So you have 2 minus 1. The third term is when r is 3. So you have 3 minus 1. And so forth. So on and so forth. So, first term r is 1. Second term r is 2. Third term r is 3. And so on. So, here, in the k plus 1th term, r is k plus 1. Right? That happens in the k plus 1th term. Remember, first term, term number 1, r is 1. Term number 2, r is 2. Term number 3, r is 3. And so on and so forth. Term number k, r is k. Term number k plus 1, r is k plus 1. So it's going to be the k plus 1 times k plus 1 minus 1. Look carefully. You see that how worked out, or how that worked out? And then that is equal to k plus 1. You can just multiply out the brackets. We have k plus 1 squared is k plus 1 times k plus 1 minus 1 all over 3. Alright. We have run out of scrolling space. We can't scroll down anymore. So let's draw a line up this way. Right, to divide the screen. And we'll continue the work on the other side of this line. Now, what we have is k squared minus 1 over 3 so we have k squared minus 1 over 3 plus k plus 1 in one bracket plus k plus 1 in a bracket there. The other bracket is k plus 1 minus 1. But that will amount to just k. So it's multiplied by k. Alright? And that is equal to k plus 1 open bracket. So that's k plus 1 in one bracket open bracket. Then k plus 1 squared is k squared plus k plus k plus 1. K squared plus k, what is it? K squared plus 1k plus 1k. Is k squared plus 2k plus 1. If you multiply it out, it's k squared plus 2k plus 1. right? So you have k squared plus 2k plus 1 minus 1 all over 3. So all of this minus 1 all over 3. Alright, in working this out, you could change up both sides at the same time, right? If you want, no problem. Now, here, well, it would look more sophisticated if you just change one side to make it look like the other, right? You could do that too if you want. But anyway, let's see how this goes. This is not just quadratic, right? We have here, you're going to have a k cube involved. So it's not like a quadratic and we can just factorize like that. So what we do, we could multiply out the brackets at the top. Well, look at this now. Let's rewrite this. This is k squared minus 1 over 3 plus, this is k plus 1 over 1 equals, let's have this part first, k squared plus 2k. The 1 minus 1 will go. So it's k squared plus 2k and k plus 1 divided by 3. Alright? To get common denominators on the left hand side, we multiply both top and bottom by 3. All of this times 3, and the 1 times 3 gives a 3. So you could write everything over 3. So at the top, multiply out the brackets, k divided by k squared, give a k cubed minus k by negative 1 is minus k plus 3k by k, gives a 3k squared plus 3k by 1 gives a 3k is equal to. Now let's multiply out these brackets. K squared by k, all of this will be over 3 now. K squared by k is k cubed. Then k squared by 1 is plus k squared. My. Have to be attending to a lot of mosquitoes in the meantime. Alright, so is what we have here is k cubed plus 1 by k squared, or k squared by 1, plus 2k by k gives you 2k squared plus 2k by 1 is 2k. Alright, so here now you have k cubed negative k plus 3k is 2k, you know. So you have plus 2k. Oh, let's put the k squared next. 3k squared plus 3k squared plus negative k plus 3k is 2k all over 3 equals. Alright, this has a k cube in it. K squared, you have k cube, k squared. Oh, I made a mistake here now. You have k squared by k is k cube. K squared by 1 is k squared. 2k by k is 2k squared. It should have been 2. I left off the 2. And then 2k by 1 gives a 2k. Okay. So now, this will be all over 3, but what is it? k squared plus 2k squared gives you 3k squared. And then you have the 2 plus 2k. Alright, so as you see, the left hand side and the right hand side are showing the same thing. So you say, not shown, it's proved. But they ask you to prove it. So that is that, it's proved.